Hi guys, welcome back to the Code Worms. Today we'll be moving forward with one more question called the combination sum. This question uses backtracking or rather DFS algorithm, and this question was actually asked in the Amazon interview quite a number of times, as well as in the Uber coding round interviews. So this is a very important question uh, regarding the preparation for these big tech companies. So let's proceed with the problem. So the question is combination sum, and it says given a set of candidates without duplicates and a number target, find all the unique combinations in candidates where the candidate numbers sums to target. Now, the same number may be chosen from the candidates for unlimited number of times. Okay, this is an important information that everyone needs to pay notice to. If the array, this line means if the array candidates consists of numbers 2, 3, 4, and the target is 8, then we can create a solution set consisting of 4 twos. That is, we can select 2 as many number of times as we want. Okay, so let us just write it down here. Suppose we have here, suppose the array consists of, yeah, suppose the array consists of 2, 3, and 4. Okay, sorry, 2, 3, and 4, right? What is this? This is my candidates array, and my target value is equals to, my target value is equals to 8. In that case, my solution set can be, my solution set can be 2, 2, 2, 2. This can be a solution set. This is what this line means. The same repeated number may be chosen from candidates unlimited number of times. That is, we can select a single number as many times as we want. There are two more important information that we need to take care of. All the numbers, including the target, will be positive integers. That is, this set candidate will only have positive integers, and the solution set must not contain duplicate elements. Okay, must not contain duplicate elements. So now, suppose, what does this line mean? This line means that if we have an array 2, 3, 6, and 7, and we have our, this is candidates for, this is candidates, and we have our target equals to 9. In that case, our solution set can be 3, 6 or 6, 3. So this is an exclusive OR. Like, it, the solution set will either contain 3, 6 or it will contain 6, 3. It will not contain both the solution sets simultaneously, because we here are not considering the permutations. We are just thinking about the combinations. And that is it about the problem. So now let's proceed with the implementation. So firstly, as they have said that they will be giving us a unique array, it is very intuitive to think about an hash set as a data structure to be implemented in the first place. But that shouldn't be the case, because first of all, if we consider a hash set, then we have to convert the array into a string of numbers and then put it inside the hash set, and then again get it back to integers and compare it with the target, and then again get it back to an array, and then sorry, not an array, a list, and then that will be our solution set. So it includes a lot of tedious work. So rather, here we'll not be using a hash set, rather we'll proceed with DFS recursive algorithm. So whenever I see a problem, the first thing I think everyone should do is define the return state, define the type with which will be our return type. Define the return type, to be very honest. So here the return type is list of integers. So that is what I will do, list of integer, and we will name it, say, result equals to new array, yeah, array list. We have defined it. Now let's just sort the array, and let's just sort the arrays dot sort candidates. Now let's make the recursive call, that is the function which will be handling most of the operations in this code or in this implementation. Get combination. What all do we need to pass? We need to pass candidates, followed by our current index, followed by our target, followed by a new array list, followed by our result, and then we will return result. That is it for the first function. And now coming to the major part of the problem. So let's just define public void get combination, followed by int candidates, followed by int index we are currently in, followed by int target, followed by list of integer, and name it, say, temp, followed by list of integer result. So this is our definition, and now we move forward. So now first, let us make a recursive call. So we will traverse through the array int I equal to current index, I less than candidates dot length I plus plus. So here the first check we'll be keeping is if target minus candidates of I is less than 0, then continue, right? Now see, as the question have stated, we need to get those solution sets which sum up to target. So if any of these elements pop up in between, which is actually greater than the target and is rendering the target negative, that means that candidate will never, that element of the candidate array will never be a part of the solution set. So we are just ignoring those elements, and hence we are using the continue keyword to move to the next iteration, right? And now what will we do? If this is not the case, that is, it does not satisfy, that is, target minus candidates is not negative, then we will add this element to our temporary list of integers. Temp.add candidates of I. And now it is time for our recursive call, which is basically the DFS algorithm that we are using, or you can also say backtracking, and that is that what we are using here. So get combination will be passing candidates, followed by the index, which is I, followed by the target, which has to be revised as target minus candidates of I, followed by the list, the temporary list, and the final list, right? So this is done. And now the last thing that we need to do is temp dot remove temp dot size minus 1, and that is it. Now, when will our condition be satisfied? That is the first question. Every time we are getting an element from the candidates array, we are sending it. We are recursively calling the get combination function again, but by revising the target value, that is target minus candidates of I. So every time we are having a reduced target value. So when will our condition be satisfied or our constraint be satisfied? That is, we have got one list of integers whose sum is equal to target. As we are reducing the target every time we are getting a possible element in the candidates array, so therefore, when the target value becomes 0, at that point we'll be having a list. So we'll keep that condition here. If target equals to 0, result, which is our return state, like which is the list of integers that we have to return, result dot add new array list and here we'll pass temp, right? This is what we need to do. And here list of integer, here we have missed out the integer. Yes, have we mentioned everything? Yes, it looks so as if we have mentioned everything. So let's just run the code once and see what is happening. Expected, we have missed out the get combination here. We have missed out the semicolon. Now we run it again. Let's see if it's judging. Yes, it's judging. And yes, we can see the output is matching with the expected output. So let's submit our solution. Yes, runtime is 2 ms and it is faster than 99.64% of the Java Online solutions, right? So what did we do basically? What did we do? We traversed through the array. We traversed through the entire array. For each and every element in the candidates array, we were checking if that element, when reduced from target, is giving us a negative number or a positive number. If it is giving us back a positive number, then we are adding it to the temporary list. Otherwise, if it is giving us a negative number, we are moving back to the next iteration. Now, after adding it to the temporary list, we are calling the get combination function recursively, where we are passing the candidates and we are passing the current index we are at, so that we can move forward henceforth. We are passing the revised value of target and the temporary list, which is holding the candidates of I for this iteration, and the result. And lastly, why are we using this statement temp.remove temp size -1? Now, for each and every element in the candidates array, we have two options: either to select that element or to not select that element. So the first half that you saw is to select that element, and temp.remove temp size -1 is used for the option of not selecting that element, right? So that is what is balancing the entire situation. And now if when target becomes equal to 0, we'll add that temporary list to our final list, which is result, and then we return result from our first function. That is it for this problem. Hope you understood everything that I tried to explain. And if you like this video, please do give it a like and subscribe to our channel, as we'll be coming up with more such interesting problems, and we'll be implementing those for you to help you guys out. And secondly, if you guys have any doubts regarding any implementation of any problem, please do comment in the comment section. Please do mention about it in the comment section, and we'll definitely do solve it for you and upload a video on that. Thank you. Happy learning, and stay tuned to this channel.